We are the Association for Child and Adolescent Mental Health, or ACAMH for short.
Hello, welcome to the Papers podcast series for the Association for Child and Adolescent Mental Health, or ACAMH for short. I'm Jo Carlo, a freelance journalist with a specialism in psychology. In this series, we speak to authors of papers published in one of ACAMH's 3 journals. These are the Journal of Child Psychology and Psychiatry, commonly known as JCPP, the Child and Adolescent Mental Health, known as CAMH, and JCPP Advances. Today, I'm interviewing postdoctoral researcher Dr. Matthijs Moorkerke, based at the Centre for Developmental Psychiatry at the KU Leuven, Belgium. Matt is the first author of the paper, Can Repeated Intranasal Oxytocin Administration Affect Reduced Neural Sensitivity Towards Expressive Faces in Autism, a randomized controlled trial, recently published in the JCPP. This paper will be the focus of today's podcast. If you're a fan of our Papers podcast series, please subscribe on your preferred streaming platform. Let us know how we did with a rating or review, and do share with friends and colleagues. Hi, Matt. Thank you for joining me. Can you start with an introduction about who you are and what you do?
Yeah, sure. Hi, Joe. Thank you very much for inviting me here. I'm Matt. I'm a postdoctoral researcher at the KU Leuven in Belgium. And I have a background in biomedical sciences and medical imaging. And my research interests lie mostly in investigating psychiatric disorders, for instance, autism spectrum disorders, or ASD, or autism, using neuroimaging techniques, but also behavioral and biological measures, and apply these in pharmacological interventions, like the Oxytocin clinical trial described in the current paper.
Great, thank you very much. Before we go into the details of your paper, I want to talk a little about oxytocin. It's sometimes called the love hormone. What do we need to know about oxytocin, and in particular, why it is of interest in the investigation of autism?
Yeah, so indeed, oxytocin is commonly referred to as the love hormone because it does play an important role in social bonding and also has other pro-social effects. But maybe first, some general background about oxytocin itself. It's produced in our brains, and it's released in both the body and the brain itself. And in the body, it plays a role as a hormone, mainly known for inducing labor and milk ejection in mothers. And at the brain level, oxytocin works as a neuromodulator, influencing our social behavior. For instance, it helps to form the bond between a mother and her child. But beyond this, research has also linked oxytocin to increased feelings of trust among peers, but also making more eye contact, better emotion recognition, and so on. And precisely these effects made it interesting to evaluate the effect of oxytocin administration in children with autism, where these type of skills are sometimes a bit lacking. And lastly, there are 2 important hypotheses on how oxytocin can influence our social behavior. First of all, there is the social salience hypothesis, and this one states that oxytocin can increase attention to and perception of social cues. And secondly, the social stress and anxiety reducing effect of oxytocin. This one enables social approach behavior.
Can you also tell us about the differential effect of acute versus repeated oxytocin administration?
Many early studies have shown very exciting results after a single dose of oxytocin, so the acute effect. For instance, it improves the ability to recognize emotions in the face or increases eye contact during a social interaction. However, if we want to yield the full potential, the therapeutic potential of oxytocin, we also need to know the effect of repeated administrations, so multiple dose administrations. And only a few studies have looked at this, but we are already noticing some differential effects. And most likely these are due to the fact that in single dose studies, oxytocin levels are increased whilst performing the experiment, for instance, say measuring eye contact during a social interaction. And on the other hand, in repeated administration studies, the experiment is most often performed after the oxytocin administration periods, so looking at longer term effects. This is probably only partial explanation for the differences between acute and repeated administration, but yeah, so more research is definitely needed there.
So Matt, let's get into the detail of the paper. So this is the paper, Can Repeated Intranasal Oxytocin Administration Affect Reduced Neural Sensitivity Towards Expressive Faces in Autism, a randomized control trial, recently published in the JCPP. Can you give us an overview of the paper?
Yeah, of course. So we evaluated the effect of repeated oxytocin administration on brain activity or neural sensitivity towards expressive faces in 68 children with autism. Here, half received oxytocin and half received placebo twice daily for 4 weeks long via nose sprays. And then the children were tested again post-treatment and then once more after a 4-week follow-up period to look at potentially longer lasting effects. And additionally, before the oxytocin or placebo nose spray administrations, these children with autism were compared to a control group of 39 children without autism to see if they indeed had altered neural sensitivity towards expressive faces.
Is there anything more you can tell us about the methodology used for the study?
So to measure this neural sensitivity I've been talking about, we used quite a novel technique called the frequency tagging EEG technique. So we measured brain activity at the scalp using these EEG electrodes and combine this with presenting expressive faces, happy faces and fearful faces, to the children at a certain frequency. And specific populations of neurons in your brain will explicitly synchronize to this exact same frequency, which we then can measure and quantify. So this is actually a very robust and objective way to evaluate brain activity, since you're looking for the same frequency in the brain activity as the visual stimulation with the faces.
And what did you find? What key findings would you like to highlight from the paper?
Well, first of all, we found that children with autism indeed had reduced neural sensitivity towards both happy and fearful faces compared to the control group. And secondly, after nasal spray administration, children with autism displayed a significant increase in neural sensitivity at the post and follow-up sessions, but only in the placebo group. And this is probably due to an implicit learning effect there. So surprisingly, in the oxytocin group, neural sensitivity remained unaffected from the baseline to the post-session. So it actually dampened an otherwise typically occurring implicit learning effect. And this is most likely reflective of oxytocin's stress-reducing effect.
Were you surprised by that finding? This is the finding that only in children with autism who received the placebo nasal spray was there a significant increase in neural sensitivity towards expressive faces.
Yeah, this was indeed an interesting and unexpected finding. We think, how we explain it now, we think it's a naturally occurring implicit learning effect, probably due to the repetitive nature of the clinical trial and also of the frequency tagging EEG technique itself, inducing a form of familiarization towards the presented faces. And this familiarization could then increase alertness towards social cues through increased neural activity.
Your results suggest repeated oxytocin administration may elicit dampened neural sensitivity towards expressive faces. Is this something that's desirable for children with autism in terms of stress and anxiety reduction? What are the pros and cons? I'm trying to figure that out.
Yeah, so indeed, interestingly, we found that oxytocin administration dampened this so-called implicit learning effect as seen in the placebo group. Mm-hmm. And many single-dose studies find the opposite effect, so that oxytocin increases brain activity towards faces. We now think that when oxytocin levels are simultaneously increased during the face processing task, oxytocin will help direct attention towards these social cues. Mm-hmm. However, based on the current results, where oxytocin was administered for a longer period of time and prior to the task, it primarily exerted its stress reduction effect. And possibly the course of this repeated oxytocin administrations may have inhibited the spontaneous increase in this familiarization and neural activity in order to soothe the impact of the incoming, possibly stressful social stimulus, since faces might be perceived as aversive for children with autism. And then, interestingly, after the 4-week follow-up, during which no oxytocin was administered, we see an increase in neural sensitivity for facial expressions in the oxytocin group comparable to the effect seen in the placebo group. So it's actually depending on the preferred goal to increase sensitivity towards social cues, or is it more in general decrease social stress? The context and the timing of administration oxytocin is important. Yeah, however, more research on how this works is still needed.
Any thoughts about what's the preferred aim for children with autism?
Probably the context during which is important. And like I said, it will highly depend on the goal you're after. If you want to specifically target a deficit, for instance, if a child doesn't make enough eye contact for a fluent social interaction, then you might preferably combine oxytocin administration with an eye contact task or an eye contact training, or teach a child during increased oxytocin levels, teach them different emotions or to discriminate between different emotions. However, if your desire is to induce a more general social stress reduction, then it might be preferable to give it in a repeated administrative way.
Yes, a really important difference, isn't it? Matt, is there anything else in the paper that you'd like to highlight?
Yes, actually, I do. I would like to highlight our finding of reduced neural sensitivity in children with autism compared to the control group, because this is actually a replication of a prior study from our lab, but this time in a new and in a larger group, including both boys and girls, and using a different set of phase stimuli, thereby actually validating the robustness of this frequency tagging EEG technique.
Was there any difference between the boys and girls?
We've included gender as a covariate and actually found no difference between both of them. Although I do want to note that the group of girls was reflective of that in the general population of children with ASD, so 1 in 4. So more research in girls only would be highly recommended.
So, Matt, what are the implications of your findings for CAM professionals and clinicians?
Well, importantly, oxytocin is more nuanced and commonly portrayed in the media as simply the love hormone, but it can impact social behavior, and thus it has the potential to help people with autism. However, we are still figuring out how exactly, single dose versus repeated, but also the context in which oxytocin is given. And there is more and more evidence of combining oxytocin with psychosocial therapy that is quite promising.
What about follow-up research? Are you planning any follow-up research, or is there anything else in the pipeline that you'd like to share with us?
We have also collected clinical behavioral data and biological data in this clinical trial, and these results are actually also available online, so as papers, as preprints, and some are still in the works. Yeah.
Finally, Matt, what is your take-home message for our listeners?
So in short, we validated, first of all, the robustness of the used technique, the frequency tagging EEG technique, to assess reduced neural sensitivity towards expressive phases in boys and girls with autism. Oxytocin is generally known as the love hormone, but it's more nuanced, it's more complex, and this paper gives some new insights in the specifics of how oxytocin works, and specifically repeated oxytocin administration may prime neural circuitry to elicit dampened neural sensitivity towards emotionally evocative phases, likely reflecting its stress-reducing effects. Lastly, I just want to say that future research should further explore this differential neural impact of combining repeated oxytocin administration with specific social stimulating tasks or contexts.
Brilliant. Matt, thank you ever so much. For more details on Dr. Mateusz Mokerka, please visit the ACAMH website, www.acamh.org, and Twitter @ACAMH. ACAMH is spelled ACAMH. Don't forget to follow us on your preferred streaming platform. Let us know if you enjoy the podcast with a rating or review, and do share with friends and colleagues.